the integral of t times e to the negative 3t dt. And since this is in the section on integration by parts, I'm sort of figuring it's an integration by parts problem. That might not always be the case, but that's kind of the trap you might fall into. If you haven't practiced it enough, then it's hard to distinguish when you look at the test. It's hard to distinguish what type of problem it is. So, but this is integration by parts, and for this one, I'm going to do this. Let v equal t. Nah, I got that wrong. U, that's u. U equals t. And then what is the derivative of u? du over dt is 1. And so if I multiply both sides by dt, du equals dt. Once I pick out u, everything else is dv. So I got the u, that's t. All of this is dv. So dv is e to the negative 3t dt. That means v is the integral of e to the negative 3t dt. Now, how do I do that integral? Some of you might do it in your head. It is u substitution. Absolutely. Now,
there's a rule where you can just do is 1 over.
Yes, there is, but I'm going to do u substitution. But they do have that rule about some formula for this. Now, I'm saying u substitution. Now, if you look at this problem, saying u substitution is sloppy on this problem. Because I already used u in this problem. And I should not use u twice in a problem, or any letter for that matter, when it represents two different things. So I'm going to call it w substitution. So w substitution. And what's w going to be? Negative 3t. And so dw over dt is what? Negative 3. dw is negative 3 dt. And I'm going to go ahead and solve this for dt. dw over negative 3 is dt. I could also write that as negative 1/3 dw is dt. So let me continue this kind of on this side here. For this part of this problem, I'm going to take it right here. So v is the integral of e to the w times negative 1/3 dw. So that negative 1/3 I'm going to factor out. Negative 1/3 times the integral of e to the w dw. And the antiderivative of e to the w dw is e to the w. And I'll not worry about the plus c to the end of the problem. So let me re-put negative 3t back in. Negative 1/3 e to the negative 3t. All right, now I've taken up a lot of space on my paper, so I'm going to have to do something like this. This entire problem that I'm started with, let's just come on down here with it. Because now I'm ready to zap this with the formula for integration by parts, which is u times v. Okay, u equals t, and v is negative 1/3 e to the negative 3t. U times v minus the integral of v, which is negative 1/3 e to the negative 3t, du, and that's dt. I have to figure out this integral. I'm going to clean this little part up. Negative 1/3 t e to the negative 3t. Now, on this, I got minus a negative, so it's going to be a plus. And I'm going to factor out the 1/3, so it'll be plus 1/3 times the integral of e to the negative 3t dt. Now, if you look at this problem, we just did this part when I found v. Sometimes that happens, sometimes it doesn't happen that way, but sometimes it'll save you a little bit of time. So there's a w substitution again, or maybe I should call it a different letter at this point, but it's the same as the one I just did. Negative 1/3 t e to the negative 3t plus 1/3 times negative 1/3 e to the negative 3t plus c. Now, I kind of did that last little step without explaining a whole lot because I want to point this out to you. The big question students will ask in the class, at least in past semesters, was, where'd that negative 1/3 come from? You already had a 1/3 in the problem. But I need that negative 1/3 right there. Why? You integrated that second time. That first 1/3 came from my first w substitution, and I repeated the w substitution right here, and it comes up again. So that makes it negative 1/9. So I got negative 1/3 t times e to the negative 3t minus 1/9 times e to the negative 3t plus c. If a problem like this turns up on the test, that is the biggest mistake students make right there. The students who pretty much know what's going on that problem. That is where they just keep that as 1/3. Okay? So warning there, that's where the mistakes happen.